Welcome. Good to have everybody here today. We're going to be talking about the pedal principle today, but just to let you know what we'll be doing at the end, we are giving away one of our new tumblers. I can't see that on there. A laser cut tumbler. It's kind of hard to see. Anyway, that's what we'll be competing for at the end of this with our 5 questions. So, the pedal principle, propelling your team with flow and small stories. So kind of the inspiration for this talk came from many years ago. We were at Agile and Beyond in Detroit. And we were doing a flow simulation thing. And my kids were filling in some spots because we needed to even out some things at tables. So there's my daughter and my son were helping with the simulation that we were doing. And Katie is now in college and Benjamin is finishing up his junior year. So this is a long time ago. But they were listening to my talk and seeing the simulation, and then they had a question for me. They said, we're talking about how in the flow we want to go ahead and finish stuff, get it all the way through. Should we apply that to our schoolwork? And we've homeschooled the kids. So the question was, why don't we finish all of English through high school, then go back and do math and then science? Because they were like, if the goal is to go ahead and finish things before we start new things, wouldn't this make sense? So we talked about this, and you'll see how this kind of relates in a minute, but let me show you my son's most recent science experiment and some of the reasons that might not work. So here's his 3 pictures of his most recent science experiment. So he set up this board on the second story landing at our house, and then had a Hot Wheels ramp that went down it, and then he took a metal ball, and you can see there's a camera in the back there. And he timed how long it took to go a meter. You see the meter stick right there. Timed how long it took to go a meter when he ran it down it, and I stood with a bag to catch it, so he couldn't see where it hit on the mat down below. And then he put a piece of tinfoil down there and drew a bullseye where he thought it was going to hit. So his goal was to predict with math exactly where that was going to hit on the on the floor. And it had, I think we had like a 15, 16 foot drop, something like that. So he took all his calculations, did the math, and I think it was within about 4 centimeters of it. And the point I want to make here is, had he gone ahead and tried to finish all of his science work before beginning math, he would not be able to do this, right? The ability to do this is dependent on having enough math to be able to understand the science. And so when I was explaining this when they were younger and they were asking me about, finishing all of one subject before going on to another, I was explaining how some of the stuff you do in one subject actually sets you up to succeed in the other, and that sets you up to kind of back and forth and to reinforce each other. So the math he had to learn in order able to do this set him up to be able to do this type of experiment, and then doing this type of experiment helped give him more experience with the math and self-reinforcing. So that's what I want to refer to here as the pedal principle. And one of the things I want to point out here is, had he tried to do this experiment before he understood the math in order to be able to calculate this, it would have been like trying to pull the rear wheel of a pedal up. And I do realize that, in fancy bikes you actually lock your feet into the pedals, which, by the way, I don't think I'd be very good at. I managed to break my foot just getting up out of a chair earlier here, which is why I'm hobbling a little bit here. But on a normal bike that you're not locked into, the way that you take advantage of that rear pedal is to actually push the first pedal first. And then when it gets turned around, then you're able to reinforce each other by pushing on that forward pedal. But the back pedal, if you put all your focus on just trying to get that back pedal to come up, it's not going to work until you do the other thing that allows you to get that rear pedal to the point that you can benefit from the investment in it. So let's think of an example here. So in the example with Benjamin, he needed to invest some in math in order to be able to take advantage of the science. And then when the science gets up to the front, he can leverage the science, which gives him more, helps put math up to where he's able to take more advantage of that. Let's think of another example here. Let's say you're a farmer, you live in a rural area, so you're wanting to start an incredible new breed of cows. Well, genetic improvement may be what you want, but until you get to the point that when you're ranched, that you've got like a stable herd that's able to make it through the winter, and you're not losing cows, and you're not dealing with predators coming and taking it, until you get that herd stabilization, you're not going to really be able to take advantage of the genetic improvements. Yes, this session is being recorded. It's being streamed to YouTube, so it will be there as soon as we finish. You can find out youtube.com/agilelnl, I think, or just send me an email. I'm happy to help you find it. Okay, so another example. I run a little local news site here and in my town, and we sell advertising on the site. It's not a big thing. It's mostly a community service, but I do like it to not lose too much money. So we sell advertising on the site, help local businesses stay in front of their target audience, and then we write news stories. Well, if I was to try to start selling advertising before we actually got any news stories out there, this is hard to do. It's hard to take advantage of selling advertising before we actually have any news stories on the site. So once again, it's that pedal principle. We write news stories, which gets people interested in the site, and people coming to the site, which then gets that pedal around to where then we can sell advertising, which we can use to fund writing more news stories. And it's that pedal principle in operation. So we can't, and you'll find this in lots of different situations. There's lots of places where the thing that you're trying to do, you can't really take advantage of until you invest in something else. And if we're not aware of that, we can assume that we're not getting any value from something. But the problem is we just need to focus on getting that first pedal. We need the forward pedal to get the attention first, and then we're able to take advantage of the thing that comes behind it. So the example and what I'm leading up to here is the idea of flow and cycle time versus small user stories. So these are both very important things, but I want to show some examples of why if we're trying to focus on making our stories really, really small without focusing on flow and cycle time, it can be very difficult to take advantage, no matter how much effort we put into small user stories, until we get that forward pedal of the flow and cycle time going down. We're not going to be able to get the small user stories to the point that we can actually take advantage of them and leverage them. Once we do, though, then the small user stories help reinforce the flow and cycle time. So we have this pedaling effect. So I was working with a team here a while back that was really focused on small user stories, but they weren't seeing much advantage of it. And it turned out the reason is because their flow and cycle time was really the thing that was keeping them from taking advantage of what they were trying to invest in the small user stories. So what do we mean by flow and cycle time? So I'm going to take a divergent thing here that I think to illustrate the point. I want to start out by asking you, how much bandwidth do you have at your house? This is definitely going somewhere. It may take just a minute. So it should pop up in the Slido thing that you can do it, or you can go to slido.com and type in that number. And I keep this up because this is the window that we're going to be competing for our lovely laser etched Agile Lunch and Learn tumbler. Okay, 100 megabits per second. Looks like most of us are in that category. 50 megabits per second, 1 gig. We got 4% of us with more than 1 gig, 4% of us that are less than 10. I've been very lucky. The last few places we've had internet, we had, being in a rural area, I remember we once had to put a T1 line actually to this house, which was 1.5 megabits per second. So very, very slow, but it was very, very reliable and what I needed for video conferencing stuff. So glad to know most of you are in the 100 megabits per second range. That's great. So this is where everybody's at. A lot of us are in the 100 megabits per second. And would you like more bandwidth? And I promise this is going somewhere with flow. So like if you had the option, you could flip a switch and have more bandwidth. Would you like more bandwidth? Or somebody like, no, don't want any more bandwidth. Or maybe some of you are still using rotary phones, so like you're not really sure what this whole bandwidth thing is. So it looks like most of us, 82% of us, are in the realm where we would be happy with more bandwidth. We've got the Luddites here, the 18% that would rather not have more bandwidth. Installed T1s, yes, they were interesting wonders of technology at the time. Now looking back, it's like, wow, 1.5 megabits, how was I able to do anything with that? But okay, so we got 23% of us are Luddites, don't want faster bandwidth, or maybe you're assuming this is a trick question, and this isn't the trick question part. You'll see the trick question in a minute. But most of us would like to have more bandwidth. Well, what if the connection to your house could transfer 200 terabytes per hour to the nearest backbone. So usually it's the connection to our house that's usually the big bottleneck. So let's just think about that, how we could get faster. And if you could transfer 200 terabytes per hour to the nearest backbone, that would work out to be like a 450 gigabits per second connection. I've got a gigabit connection here. That's 450 times what usually what's considered about top of the line. I see 4% of us had something faster, but this is a really, really fast connection. So how would you like a connection that speed? Well, let me show you an example of something that speed. Okay, so here we have what I'm going to call Donkey Net. Okay, and he's got this little donkey has about 50 hard drives on his back, and if those each hold 4 terabytes of data, we could calculate out that, and let's say the donkey can walk to the nearest major backbone and back in an hour, with 54 terabyte drives, we're now dealing with the bandwidth of about 450 gigabytes per second. Is what it would work out to. Okay, so now the question is would you rather have your current connection or this higher bandwidth donkey? So keep your current connection, let's go with the donkey, or I'm willing to go without internet if I get to have a donkey at home. So think of your current connection, which most of us said we would prefer a faster connection. And I've just shown you this is definitely higher bandwidth than what you have today. Okay, Richard sees where we're going with this. Okay, so a lot of us now some of us are like, I'll take the donkey. I'm willing to go without internet. Donkeys are cute, they're fun, and we had a donkey at my parents' farm, and he was very friendly until he wasn't, and he would pick up goats and throw them across the pen. So we learned not to put goats with him. But for a while there, he was donkeys are cute and a lot of fun. I've got a neighbor down here that has some that make a lot of noise at night. I don't mind it. It's really cute. But he said it's hard to beat coming home and having a bunch of donkey kisses. So 10% of us are, okay, I'm selling the donkey thing. 10% of us are saying let's go with the donkey. 16% say I'd rather have a donkey, forget the internet. 74% of us are saying, you know what, I think I'll stick with my internet connection. This may be higher bandwidth, but there's something about it that makes it less preferable than most of us with our 100 megabit connection. Donkey latency, yes, that is a good way of putting it. So what is it about your current connection that makes it better than DonkeyNet? Well, even though we can move lots of data, it takes too long from start to finish. So the fact that the donkey is actually moving more bandwidth, our flow and our cycle time, like imagine you're actually sending a single click somewhere to a web page to get something back. The donkey has to walk for 30 minutes to get the nearest backbone, it uploads it, and then it walks it all the way back. And my point here is that even though the bandwidth or the magnitude of what can be sent or done is greater, the cycle time and the flow, how long it takes for something to get back, makes it seem nearly useless. Years ago, I had Vonage, for voice over IP for phone system. And this was probably early 2000s, I think, maybe 2001, 2002. And a friend of mine, a guy that worked with me, had just gotten satellite internet, and he was wondering if he could use, and this was way before Starlink, so extreme latency, and the way that packets get sent, latency was even as worse as you could possibly imagine. Anyway, I said, well, here, let me send you the stuff. I'm not using it today. We're going to be out of town, so I don't need the phone. Take it and put it on your satellite internet connection and see what happens, because he was thinking about buying that. So he set it up, and he had a satellite internet connection with Vonage hooked to it, and he called himself on the cell phone, and it rang, and he said, hello? Hello? Nothing happened. Hello? Hello? And then he whistled, and then he started hearing himself say hello, and he said there was about an 8-second latency delay in that. And it wasn't that he didn't have enough bandwidth. You know, the satellite was perfectly enough bandwidth for what he needed, but the cycle time and the flow of how long it took for those packets, for whatever reason, the way it was working, was about 8 seconds to get all the way the trip all the way through, which made it very useless for doing phone stuff over. So it could move plenty of data, but it took too long from start to finish. Well, okay, now with our analogy here, let's say I know what we need to do. We need smaller amounts of work. We need smaller story sizes here. So what if we reduce the amount of work being done? So we'll give the donkey a single hard drive. And this is where AI breaks down. I could not get AI to give me a donkey with a regular sized hard drive on its back. Um, in retrospect, I guess we were kind of stretching. If AI is looking at other pictures that have gone before it, the idea of a single hard drive on a donkey's back isn't something that evidently is out there enough that people are trying to do it. But anyway, let's say we go to a single hard drive, and let's say we'll even pretend it's a small hard drive. It's 10 megabytes hard drive, really, really small. I think that's how big my first hard drive was in the old 8086 computer. Anyway, it's a really, really small hard drive. Well, have we solved the problem? Well, no, we've reduced the size, but there's no improvement to the flow or cycle time. No matter how small we reduce the amount of work or the amount of that the donkey is taking back and forth, we haven't improved the main issue here, which is that the flow or cycle, there's so much overhead of delivering the work that it makes it useless to us for most usages. If you were trying to just back up your computer once a day, maybe the donkey with all the hard drives would be beneficial. But no matter how small we make the donkey's load, we won't see any improvement until we increase the flow. And so the point I want to make here is that when we're looking at flow, cycle time, and small user stories, we can invest a lot in small user stories. And you may run into teams that are saying the small user stories, we're trying to do small user stories, but we're not seeing any benefit from it. Well, the reason may be is they may be in the same situation with the donkey. We're putting less and less on the donkey, but there's still too much just overhead time of delivering the story. So if every story has 4 weeks of delivery overhead, making the stories smaller might not make any improvement that you can actually see. As a matter of fact, in some cases, it might be just like trying to pull up on that back pedal. It might make things worse. You might fall over and break your foot, something like that. So we need to push on the pedal of flow in order to get the benefits of having the discipline of small stories. If we do them in the other order, it's not that the small stories aren't a good thing, but to take advantage of them, we actually need to be focused on flow. So let's talk about a few ways here that we could actually potentially improve flow. How could we actually improve flow? And a couple things I want to point out is just if we're measuring the right things, for many teams, just measuring the right things raises the attention being spent on flow. For measuring the wrong things, we can send ourselves in all kinds of crazy directions. There's a talk, I haven't given it for a while, but misleading with metrics, where we pretend we're going into an organization and trying to mess them up because they're nefarious evil incorporated. We're trying to mess them up just by giving them metrics to focus on that sound really good, but will wreck their development process. So what are some things to measure? So just 3 things I want to throw out here that can be useful things to measure when it comes to improving flow are cycle time, days, the number of days in a particular column, and cumulative flow diagram. So let's look at these. So cycle time is very simple. It's how long does it take to get between 2 points. A very common cycle time would be from the time we start development work until we finish development work. How long does that take? And is that number going up? Is it taking longer and longer? Or is that number going down? Now, one thing to be aware of when you're dealing with cycle time is that you want to measure things that actually produce value. If we just look at, like, how much does it matter to the user what your cycle time is on your requirement stage or just your testing stage? Well, if those things don't actually result in code being delivered to the customer that they can use, that cycle time may not matter if there's another part that has a really, really long cycle time. So the cycle time is between 2 points, but you really want the ending point to be something that actually gets stuff into the user's hands. So from when we started development work to the point that the user is saying, yes, this is what I want, I agree, it's been delivered, is the one that's really probably most important. You measure cycle time in lots of different areas. Another useful thing to be thinking of in terms of flow and cycle time is the days in columns. So how long has this story been in this particular column? If your work moves across the board and you have different columns that the work goes into, knowing how long a particular piece of work has been in that column is a very useful thing to just have a visual idea of, is something stuck there? Does this require more attention? Are we really slowing down? Are we speeding up? So if you imagine, if you were moving sticky notes across the board, you could every day in your daily stand-up put a dot on that sticky note for that particular column to show how long it's been there. And if you come in and one's got lots and lots of dots, but others don't have any, you might question, why is this one have 24 dots in it? Now, what I just described here, a lot of you probably are not using just boards on the wall. You might be using something like Jira. And Jira actually has this feature. So these dots, if you've seen them in Jira, and you can turn this on and off, I think it's actually called days in column, will show you more dots for how long it's been in the column. And then if you mouse over it, it will say the number of days it's been in that column. This is a very, very useful thing for a daily stand-up to just be say, okay, how long have these things been in progress? This one evidently hasn't been in progress very long at all. This one's been longer, but this one right here, why has this been here so long? Oh, look, it's been here 24 days. Is there something we can do to actually move this forward? Question about differences in metrics. So one thing I will suggest is a lot of times if you're dealing with Scrum, you start thinking in terms of velocity. I find velocity it's an interesting metric, but I don't think it's as useful to me, at least, as the number of stories measured in whatever units of work we can deliver to the customer, and we'll talk about stories more in a second, then the number of story points that have been completed in a given sprint. And one of the reasons that where velocity can be off is if you have work that's flowing from sprint to sprint, you could have stories that are taking a year to complete. Like let's say every story you do takes a year to complete, but you've been operating for a year. So every sprint you complete 25, 90 story points or whatever it is, but those actually took a year to actually get through the entire process. If you were in that situation, the velocity would look really, really good, but it kind of obscures that your flow is really, really slow. Most of the time people aren't using it like that, so if people find it useful, that's great. But I find velocity is a lot less useful in terms of flow because there's ways because they're kind of made up numbers, if you will, in terms of story points. I'm more interested in how often do I get something into the user's hand. I'm not saying don't ever use it. If you find it useful, that's great, but just be aware of what the limitations are on it. Okay, next thing that's useful to measure here, cumulative flow diagram. This can be very, 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 very powerful. There's lots of math that can go on with a cumulative flow diagram. Two things that it shows you that's very useful is the work in progress and the cycle time. So if you look here on a cumulative flow diagram, so the blue here are the things that are done. The yellow are the things that are in progress, and the green are things that are being added, are things that are new. So if you notice here, as the number of things have moved to done, we've started working on new stuff and we've added new things, right? So we started working on new stuff and we've also added new things to our to-do. So that green is basically your backlog of things that you haven't started yet. The orange is the stuff that you are working on. And if you notice, as we come here, as the blue goes up, that means we finished something. And then the orange goes up, which means we added more stuff to it. So this kind of just shows you it gives you a good idea of what's going on in your queues. And this distance right here, the up and down of this particular on the orange, is how much work is in progress. The same measurement on the green would be how big your backlog is. And then the blue would be how much work you've actually done. So work in progress is the up and down. This is your cycle time, which is how long, when we start on something, how long does it take till it moves to the blue, which is where it's been done. So this gives us both of those, the cycle time and the work in progress. And if we look up here on the green, the cross measurement on the green would be the cycle time, which would be your lead time. Once we add something to our backlog, how long does it take before that is actually it's completed? So this is really, really useful, and there's lots of calculations and things you can do from this. But just this idea of recognizing, even just looking at this and getting people looking at this and saying, okay, what are we doing? And so I was working with a team, and they're getting stuff done, but the amount of time here, this measurement right here, the cycle time, takes a very, very long time from when they start something until they finish it. Some of that might be improved by having shorter stories, but in the particular case that they're dealing with, what's happening is their work is built around things that tend to reward starting new work rather than finishing what's there. So it takes a long time for something to be done because they keep adding stuff. It's easier for someone to start a new story rather than going and helping somebody finish a story that's already in flight. Which kind of brings us to this idea of celebrating finishing. If you're wanting to increase your flow, decrease your cycle time and increase your flow, we want to create a culture that celebrates finishing, not starting. So, and this is a subtle thing, but if you listen to the way people are talking, if you listen to the way that people talk about things when they're working with, like even in the daily stand-up, if it's like, oh, I finished my story and so I started a new one, and everybody's like, yay, you started a new story. That's not what we want. What we really want to be celebrating is if you got capacity, let's say you finished something, did you help somebody else finish their story? Because that's what will actually help with flow is, are we organizing the way we work and organizing the way we interact as teams around trying to finish stuff rather than being in a situation where it's all cowboy coders and you got to get your new story so you can move on. One group I was working with was when they got to the end of their product increment, somebody was commenting how good it was that they had managed to start all the stories even though they hadn't completed them. And what they were trying to call out is we must have sized things correctly because we were able to start everything. So I was posing the question and saying, okay, we've got all this work in progress because we managed to start everything. Would we be happier with, should we be more happy if we had have started half as many things and actually finished them? Would that have been a better place for us? And not to say that, it's a bad thing if you don't finish your story, if you have some stories that roll over. But the point was, if we're getting excited and focusing too much on it being a good thing that we've started new stuff, where we really want to say, I can't trade the work that I did on things I just started for completing stuff that had been started before that. We want to celebrate actually finishing things. It would be better to get to the end of our product increment and have some things that we chose not to start if it allowed us to actually finish some of the things and deliver it to the customer to where we were able to start getting a return on investment from it. So if you're in a situation where you have really, really small stories, but poor flow, like the donkey example, development may finish really quickly, but that's not the bottleneck. You may be able to get your story done really, really fast, but it takes 4 weeks for it to get through the rest of the approval process or into the hands of your user. So we can quickly put a packet of data on the donkey, but it takes an hour for him to get where it's going. That's a situation where, yes, we're working with very small units of work, but we don't have good flow. So other situation where we've got really good flow, but very, very large stories. Well, in that situation, development probably is going to be the bottleneck because you're waiting for them to finish a very large story. So you're not it takes a long time before we can use any of the work that's being done. So if we have a story that's really, really large and we're not going to give it to the customer until everything's done in it, there may be pieces of that would be valuable to the customer, and we are deferring our ability to get a return on investment from that by having an overly large story. Now, an interesting thing here is we talked about the pedal principle where you're pushing things forward. It actually can work in reverse too, in a negative way. If we have really, really large stories, we may be more comfortable with having impediments to the flow or really, really long delivery cycles because the stories are so big that we can't take advantage of the faster flow. Well, then once we have slower flow, it may make it to where it's easier for us to justify having bigger stories. And so it's almost like pedaling in reverse toward a direction we don't want to go. So both of the point I want to make is the reinforcement the virtuous cycle, we'll call it that, can work in the forward direction, but it also can work against us in the backwards direction. So just a question for you. What is the forward pedal on your team? So right now where you are, would you get the most advantage out of focusing on flow and cycle time, just where you happen to be today, or would you get more of an advantage by focusing on smaller user stories? There's not a right or wrong answer here. I just want us to be thinking about, in our particular situation, what is the thing that's holding the team back? And once we invest in the correct the forward pedal one of these, it will put us in a position that investments in the rear pedal will actually help reinforce things. So like I said, there's not a right or wrong answer here, but we should ask ourselves this to make sure we're not putting all of our effort into an area where it's least likely to help. It looks like most of us are saying it's the flow and cycle time that's actually the thing that would give us the biggest advantage right now. And that could be true today and different tomorrow. Once we start making improvements in that, it may be the story size that really matters. So I was trying to just illustrate. So in this case, we've gotten to where the flow and cycle times, we've invested in that enough that now the small user stories need to be invested in order to get the flow and cycle time back up to where we can start moving forward. So let's talk about story sizes. So what makes for a good size story? So actually I'm running short on time, so just think of this in your mind. I'll skip that, but what makes for a good size story? Here's how I would define it. This is something good to reflect on from time to time, but I would say it's the smallest change that makes a user smile. So a good story will make someone who uses your software smile. Their life is somehow better because you've taken this story, a work of fiction that describes how their life could be better, and you made it a reality. If no one is happy to see you deliver a story, then why are you doing it? This is somewhat general, and there may be situations where you have to do something that your users don't even like, but generally thinking in terms of it, it needs to be something that's making someone happy. I like Richard's thing, smallest change that we can examine and learn from. And that can be a good way to think of it as well. I would just say, though, if you're dealing with that particular definition, though, can push some teams to where they're doing a lot of stuff just for themselves, for the team itself, that are more on the task level than being something that's user-centric. So I usually encourage teams, if they want to use tasks, that's great, but think of the stories as being something that that a user could actually demonstrate to you and show you how it makes their job better and then hopefully smile about it. So what is a user? Now, this is where things get really kind of tricky because all of a sudden we start having users that's a system. So as the system, I want there to be a database so I can store data. That's not really a user-centric story. And this question, who is a user, kind of reminds me back, this is a Rembrandt painting of the Good Samaritan. And if you remember the story of the Good Samaritan, somebody came up to Jesus and said, well, who's my neighbor? And the reason they were questioning that is because they wanted to exclude certain people from the definition of their neighbor. So Jesus tells this story about the Good Samaritan comes along, helps somebody who really was kind of considered his enemy, and pointing out that the definition of who's your neighbor should be very, very broad, not as narrow as the people that were asking the question. So when we're talking about user stories, we usually end up with a similar thing, like who's my user? Although in this case, it's kind of the opposite of what the people that were asking Jesus, they were wanting a really, really narrow definition so they could exclude people. Oftentimes when people start saying, who's my user, it's like, well, it's the system itself, and it's the developers, and it's the people in security, and it's all these different things. And I would suggest that when we're thinking of who is my user, we probably want to aim towards somebody who's outside of your team who interacts with your software. Because if we start making it very centric on us, the developers, or people that don't actually benefit from the software, it's not going to be tied as closely to the return on investment that comes from it. So someone outside of your team who interacts with your software, maybe a better way to put it, somebody that benefits from your software. That could have several degrees of separation and stuff. But the question of who's the user is an important one, and I would suggest, unlike who's my neighbor, where we probably want a very broad interpretation of it, who's my user, we probably want to, we have our innate desire to do things from a technical perspective rather than from the value it provides to the end user will make us want to have the who is my user be broader than it probably should be. So think about that. And I'm not trying to say there is a definite answer for it, for who's your user, but try to make sure that you're tying it to somebody that's getting value from your software and not just yourself. Now that might be other technical teams. If you're writing software that's then going to be consumed by another team, they may actually be your user. You may be several degrees removed from the actual person who's paying for your software. So there's a lot of nuances to this, but I would encourage you to make sure that you're not making the definition of user so broad that it's not tied to the return on investment that you get. Okay, so recapping, what we were talking about is the idea of a pedal principle, particularly related to the idea of if we invest in flow and cycle time, that gets the other pedal, the rear pedal, up to where we can invest in smaller stories, which then makes it easier to invest in flow and cycle time. If we start out by investing in just creating smaller stories before we've made any investment or putting effort into improving flow and cycle time, we might not see any advantage of creating smaller stories. And you might run into a situation where the team's saying, there's no reason for us to make these stories any smaller because it doesn't help us in any way. And if you hear that, that may be true. That may be completely accurate assessment of what's going on. And it might be because the cycle time is so long that the smaller stories don't actually have anything that they can leverage yet. So if you think of that pedal principle, hopefully that's a useful way to think of that. Okay, so now let's give something away. How are we doing on time? I think we're pretty good here. Okay, so like I said, you're competing for this fabulous tumbler made in Fort Scott, Kansas, by a guy with a laser engraver. I do not have a laser engraver, so somebody else had to make this for me. But the very, very fine, says Agile Lunch and Learn. You can show everybody what you won, and boast of your skills of having to remember these 5 questions and maybe having a internet connection that was fast enough to click soon. This is a great example, right? If we were using DonkeyNet for this contest, anyone using DonkeyNet would probably fail because it would be hours before the click would come through. So go ahead and join. If anybody's having trouble joining, let me know. You can also, if your phone is faster or you're on something that doesn't let you use Slido, you can use that QR code or go to slido.com and type in the number. So I will give it just a few more moments here. Everybody join. Okay, we got quite a few people that aren't joining. So evidently my Tumblr isn't as cool as I thought it was. So if you live out of the country and you win, we will do our best to get you something of equal value if I can't send this internationally. I have not tried doing that yet, but we will make sure we reward your efforts one way or another. So go and join if you haven't. It's more fun than if you participate, and we will get started. There we go, we're up to 34 now. Okay, according to this talk, which is not a measurement, you can watch the not a measurement that can help improve flow, cumulative flow diagram, cycle time, days in column, or team velocity, which is not a measurement that can help improve flow. So yes, it was team velocity was the one that isn't really designed around flow. The cumulative flow diagram, the cycle time, and days in column are all things that can help us improve our flow. Team velocity is, and like I said, if velocity is useful to you, that's great, but just make sure you know what it's actually measuring, and it's measuring something different in most teams the way it's used than flow or cycle time. Okay, what are 2 things that you can see in a cumulative flow diagram? 2 things that you can see in a cumulative flow diagram. Is it return on investment and cost of delay, work in progress and cycle time, resource utilization and lead time, or weight and height? I'll give you a hint, it is not weight and height. Okay, 3% of people got weight and height. Okay, work in progress and cycle time, yes, that is it. Remember the up and down shows the amount of work in progress or the amount of Q in that particular column or state, and the back and forth shows the cycle time. How long does it take when something comes in until it actually leaves and finishes that particular process? So our leaderboard, we've got Richard in the top spot, followed by Allison, Jair, Jake, and Rob. Next question. Did I have a typo in the measurements on the first question? Okay. Well, it'll add some randomness to it. We should celebrate starting, not finishing, cycle time, not flow, neighbors, not users, or finishing, not starting. What should we celebrate? Yes, we want to celebrate finishing, not starting. Because the thing that gives value to the user is taking something that's in progress and getting it to done. We don't want to be in a situation where we're rewarding starting work over finishing work, because then we just increase our cycle time, decrease our flow, and increase our work in progress. So we want to reward and have the way that we work and the way that we culturally interact with our team built around celebrating finishing stuff more than we're celebrating starting stuff. If the people that finishing stuff get a small clap for finishing stuff and a really loud clap for starting things, you're focused in the wrong way. If you go to places where one-armed bandits are illegal, don't think I've ever walked around the Las Vegas airport, but my understanding is you've got all these machines, and everybody's, even at the airport, they used to, I don't know if they still do. So people putting money in the machines and putting the thing that gets celebrated is when there's a payout of any type. So you hear all the noise from people that get it, and to celebrate they get it. They don't focus on how many coins go into it. It's not a big deal, like big loud alarm that somebody didn't win something. So what's celebrated is what gets attention. Okay, leaderboard. Allison, Richard, Javier, I'm not sure if I'm saying that right, Rob, and Macker. Next question. We've got 2 questions left. What did Mark say makes a good user story? Is it the largest happiness provider, smallest improvement that makes a user smile, a complete technical details of how work should be done, or a fully filled out Jira ticket? What did Mark say makes a good user story? And yes, the smallest improvement that makes a user smile. Complete technical details of how work should be done probably isn't what, for various other reasons, might not be what you want in your ticket. We want to focus on what's that smallest thing that gives a return on investment. Okay, Allison's still in top spot, followed by Richard, Seda, Macker, and Rob. I think this is the last question. So what was the problem with Donkey Neck? Was no problem because it was so high bandwidth. Bandwidth was so high there was no issues with it. Was it extremely high bandwidth that got offset by extremely long cycle times? Was it local sound ordinances that don't like the sound of donkeys? Or rapid flow but really low bandwidth? Yes, it was extremely high bandwidth. We could move terabytes, 200 terabytes of data very, very easily, but with extremely long cycle times. It took a very long time for the donkey to get to wherever your point of presence was and hook the... How would a donkey hook up the internet? There had to be robots there doing that, I guess, in our example. Okay, I think that's it. So congratulations. Oh, Richard zooms to the top spot. So congratulations, Richard. Send me an email. Give me your address. And I don't need your size because we've only got one size. And I will get one of these headed to you later on this week. Okay, hardest question according to this talk, which is not, probably that not did not help in there. Maybe. So thank you so much for coming. Next Tuesday, we've got, let's see, we've got the Kibbe company coming and talking to us about some things with communication. We had a brief discussion with, I had a discussion with them, and it looks like it's going to be very, very interesting. So I encourage you to come to that. You should have the invite. If you don't, reach out or go to events.agilelunchandlearn.com. And I am going to stop my streaming here, and I'll stick around if anybody has any questions or comments or thoughts that you want to share.